Hi folks, and welcome back to the WTF. Now in the last video we had a look at my latest project, the linear amplifier, which was just on a bare bones heatsink. And what I've done now is I've packaged it all up and I've turned it into a box, which actually looks pretty cool. In fact, I've renamed it the Predator, because you've got to give an amplifier a name, haven't you? Anyway, what I thought I would do is give a quick demonstration of what we've done here, and I'm about to go on the radio on the AM net on 3615 using this amplifier. So let's have a closer look and I can show you what I've done to turn my little amplifier board and heatsink into this awesome looking amplifier. So this, ladies and gents, is my new homebrew linear amplifier, which I've called the Predator, and it's certainly not the most powerful amplifier in the world, as Clarkson would say, but it actually looks quite cool. I'm quite pleased with it. And what we've got here is the MRF 300 amplifier board, which is water cooled. We have an arduino display there, displaying, if I can get it into focus, which displays our amperage or current, voltage, temperature, SWR and power. And it's all put into a nice aluminium chassis. Anyhow, what I'm going to do is remove the plastic top so we can have a closer look inside. Well, we're going to take a closer look at this and I'll show you what I've done. I have to admit that I'm possibly a little bit disappointed with the MRF 300s. I know there's lots of people out there in YouTube land who've built up MRF 300 amplifiers and they can demonstrate putting out 600 watts on every single band, but I think that's a bit optimistic. My experience with these LDMOSs is not so optimistic. In fact, as you saw from the last video, on the 40 meter band I can just about get 500, 450, 500 watts out of these, and I think that's probably related to the fact that at 50 volts or 54 volts, which is what I'm using from a flat pack 2 power supply, the impedances change slightly, especially with the type of output transformers I've got. And I think that to try and get it completely broadband, it is certainly, I don't think it's as quite as simple as they make it out to be. And certainly when you start putting on low pass filters on the output of these amplifiers, the performance does flake off a bit. The problem with these LDMOSs, these MRF 300s, and I'll see if we can. I've actually got a picture somewhere which I'll put up. The output of these without a low pass filter is really dirty, and there's huge harmonic, especially the third harmonic is only 10 dB less than the fundamental. And when you've got that sort of problem, when you've got that sort of broad frequency of outputs, then you know, once you start trying to put filters on the end, you're going to lose some of that power. So I think when people sort of demonstrate these without a low pass filter, I think they're kidding themselves really, because you can't really, you shouldn't really be using an amplifier board like this without a low pass filter. You're just going to be causing harmonics everywhere, and this is certainly not my experience. I know my mate Ian, G6TVJ, has bought one of these boards, and his experience was very similar to mine. Is that the output's very dirty, and unless you use a low pass filter, the output power isn't as certainly is not as good as they claim it is in the real world, so to speak. But anyway, enough of that. We've built it and it does work. It's pretty good. It's not too bad. I've got it rigged up to this homebrew transmitter that I built a while back. I think that might be in some previous videos. This is my modular 80 meter transmitter AM CW. Puts out about 10 watts carrier on AM, and with the appropriate attenuator using this amplifier, it works quite well actually. It sort of boosts the signal up to quite a nice about 100 watts PEP. I mean, you could probably put a bit more juice into the amplifier and get a bit more power out, but it's not really that necessary. So what have we got here? Let's have a closer look, and I can show you exactly what we've got and what we've done. Got to zoom in a little bit. So at the bottom is the board. You might, some of the sharp-eyed amongst you will probably notice that the board is a different colour. This was a sort of an upgraded version that I did compared to the original black one. So this is the new board, and they're just one or two minor changes that I had to do on it. So we're powered by about 54 volts for this amplifier, and we've got a suitable power supply which is capable of supplying the current. And the input of the amplifier goes via a small 3 dB attenuator that's on the board. The output goes to this low pass filter. Now it's this amplifier, I've designed it for 3 bands. The low pass filter board that I made up for it, again I designed this on KiCad and had it made. My only criticism of my low pass filter board is probably a little bit on the big side. I could have made it a bit smaller, but it's 3 bands, and the low pass filter values are taken from W6PQL, I think his call sign is, who's got quite a good website on LDMOS linear amplifiers. So that's the low pass filter, and it covers 80, 40 and 20. Now on 40 meters, the 40 meter band will actually cover 30 meters, that's 10 megs, and the 20 meter will cover the 14 megahertz band, obviously, and apparently it will also cover 21, and I think that's it. Yeah, I think possibly 18 as well. So that filter is suitable for those 3 bands. So it's not quite just limited to 3 bands. It will, in theory, cover other bands as well. We've got this little unit here is a little DC-DC converter which converts the 50 volts or 51 volts, whatever it is, to 12 volts to operate the cooling system and also the relays and things like that. And this little board, I don't know if you can see it, let's just move the camera slightly. Bring it down, focus it a little bit. This board here on the side is a DC current switch, and it also measures the current. It's got there's a current sensor there, which provides information for the arduino display. This current switch is controlled by a FET, and when that is grounded, the DC then flows through this transistor. So it's a useful way of switching on the DC to the board without having to use a big relay, I guess, because the current going through this amplifier is up to sort of 17 amps when it's going on some of the bands. So it does take quite a lot of current, as you'd expect with a solid state setup. And I've got lots of LEDs to show me that when that current switch is activated, when I put the transmitter on, you can see that there's lots of nice little bulbs, LEDs there on the board, which helps to tell you what's going on. The other board that I've got here in the middle here is a dual directional coupler, which measures the SWR and the power output, and again that's rigged up to the Arduino display. One thing you'll notice on this is the water cooling system. Now, I initially thought about making an air-cooled system using a heatsink and, you know, a fan, you know, the more conventional way, I guess, but I managed to get some water cooling blocks from my friends Ian and Paul Bennett, G6TVJ, and it seemed quite logical to try and use water cooling, because it certainly is certainly more effective than using a fan. I wouldn't say it's necessarily quieter, because this water cooling unit does have fans on it. That's actually a PC water cooling unit. It cost me about 50 quid off eBay, and it has an integral radiator and fans, and also the water pump. So I can actually turn this on manually. I'm not sure if you'll see it with the light. I'll turn it off again. So the cooling system actually can be operated either manually by flicking that switch, but there is a heat sensor on the copper block on the PCB, which is rigged up to an Arduino. I'll just show you that. I'll just take the camera off here. Let's see if we can have a look at it. So on the side there is my little Arduino Nano, which I programmed with ChatGTP, because I know nothing about computer or microcontroller programming. And if anybody's out there who wants to experiment with Arduinos and microcontrollers and you haven't got a clue about programming, ChatGTP is your answer. So that's what I did with that, and I made up this quite nifty display, as I mentioned before. So that's the Predator RF amplifier, and I guess you're asking, why did you call it the Predator? Well, it's the green blood, the green alien blood that glows in the dark. Remember that when the Predator gets injured, all that green oozy fluorescent blood comes out of him, so hence the reason it's called the Predator. The next project will be called the Alien, then we'll have Alien versus Predator. So there we are. I did give a demonstration of it working before, so I'm going to actually go on the air with this, and we'll take a few clips just to show that it does actually work. And you know, most people who have amplifiers demonstrated on YouTube just sort of show them sort of putting a bird hard over or some other similar power meter. But here at the WTF we like to show you the actual amplifier in action, actually being used with an appropriate transmitter, homebrew transmitter, and an appropriate receiver, which is what it should be used for. So with that, let us take it on the air.
From Justin, go through Ian and then Ray and then to Philip. Ground future. Over.
GW0 FZY returning. Yeah, okay there, Les, thanks for that. And morning to the other joiners. Let me just get my piece of paper. Ray, you were a good signal actually. You're about 15 over 9. And I've also heard Stuart, also quite a good signal with me, probably about 15 over. Everybody's coming through reasonably well. Just for the benefit of you, Ray, this is a bit of an interesting setup that I've got here. I'm running my homebrew 807 rig, which normally puts out about 10 watts, which is it uses a unit from a PT175 in the modulator. It's one of these sort of modulator units. Don't ask me what the modulator valves are. I've totally forgotten. But anyhow, it's 10 watts out from an 807, and it's going into an attenuator, and the signal is being amplified by my new homebrew LDMOS solid state linear amplifier, which is ticking along quite nicely. So producing about 120 watts PP, so about 25 or 30 watts carrier thereabouts. I think it was a bit more than that. Might have even been 40 watts carrier. But that's the setup with the what you're listening to today. So a bit of modern RF electronics and some vintage stuff as well in combination. So with that, we'll keep it going round. It's a lovely day here in Swansea for a change. We'll make the most of the nice weather. So back to you then, Ian, and yeah, I'll have a look at those recordings, by the way. I'll have to have a look at them. G6 TVJ from GW0 FZY.
GW0 FZY G6 TVJ returning. Yeah, okay there, Justin. Good signal from you there, actually. Quite variable, but when you're very strong, you were about 20 over 9. I can hear a hint of Dan Fett's record player hum, which is by no means a criticism. A nice warming characteristic of your signal there. Shows how strong you were on peaks of your over, but there is quite some deep QSB, but say all stations heard so far in Bristol there, yeah, fine on the LDMOS. Yeah, those dreaded three-legged fuses, they can give a lot of trouble, but definitely worth experimenting with there. It's certainly useful to have a solid state amplifier, a sort of go-to solid state amp for, you know, portable operation or experimenting, that sort of thing. Yeah, Ray, your 19 sets are pretty good actually. Quite crunchy audio, but I mean that in a good way. I take it you're probably...
So folks, I hope you enjoyed that demonstration of my latest project, the MRF300 LDMOS linear amplifier. So what's my verdict? Well, I think that for simplicity and for ease of build and the sort of power you can get from these transistors, they are in a T0247 package, which makes things possibly a little bit easier. But if you're going to build one of these, just prepared to be disappointed. You're not going to get huge, well, my experience is you're not going to get, you know, kilowatts of power from these, and I think they're not the most efficient transistors in the world by any means. I think I tried all sorts of things to try and improve the efficiency. I sort of experimented with different arrangements of output transformers, you know, different cores and things like that, and I couldn't really get them to get much better than what you see or what you saw demonstrated in this video and also the previous ones. The MRF300, you know, for a budget LDMOS transistor, I mean, they're about 50 quid a pop, and you know, I guess if you do blow one up, and I will admit that I have actually lost more than a couple of transistors in this project. They are very finicky in terms of how much drive they require, and if you're going to build one of these, just make sure you use an RF attenuator, because I blew the gates up on a couple of transistors, you know, even with RF attenuators in, and I thought I wasn't running you know, huge amounts of power. I mean, I very rarely went above a couple of watts, but on I think it was 14 megahertz, that particular band, the transistors are seem to be very sensitive, and I unfortunately lost a couple of MRF 300. So they are sensitive, and you know, if you are going to build something with these transistors, just bear that in mind, because otherwise you will lose transistors. But as I said, in terms of the, you know, the cost and the simplicity, I think you can easily get a few hundred watts of power. So from that point of view, they're quite good for QRP. In fact, they're excellent for QRP. If you've got a QRP rig you want to boost up, they're quite useful for that. Anyhow, enough of the waffle. Thanks for watching. Hit the subscribe button and all the rest of that sort of thing. And hopefully we'll see you again for the next project. Cheers for now.